For those of you who grew up in Montana or any other arid region, you're probably familiar with forest fires. For those of you who grew up in a city, you may be familiar with smog. Whether it's fire season or a smoggy day, you may be familiar with the consequences, which are reduced visibility, air that's more difficult to breathe, especially if you suffer from asthma or another respiratory illness. Poor air quality can greatly reduce quality of life, but regardless, it's something that many of us have had to deal with, sometimes for extended periods of time. Today, I want to highlight a few important air quality topics. Ambient air, the 6 criteria air pollutants, the National Ambient Air Quality Standards, which include primary and secondary standards, the primary and secondary air pollutants, and also something called the Air Quality Index. In fact, in the United States, we benefit from the passage of the Clean Air Act, which has greatly improved ambient air quality. Ambient air is the air you breathe outside. It's not indoor air, and it's also the air outside that's closer to the ground surface. Prior to the Federal Clean Air Act, a few states took measures to monitor and control air quality. However, many cities still suffered from poor air quality. For example, several smog episodes in the 1960s led to hundreds of deaths in New York City. Highly publicized smog events also occurred in London, and smog remains a major problem in several cities in China and India. In fact, with the decrease in transportation and economic activity due to the ongoing pandemic, many places have experienced much better air quality than normal. Here are a few images taken in India before and then after the coronavirus pandemic lockdown. The Clean Air Act identifies 6 criteria pollutants. These are ground level ozone, carbon monoxide, sulfur dioxide, small particulates, nitrogen dioxide, and lead. Most of these emissions are either directly or indirectly related to the combustion of fossil fuels, including petroleum burned in cars, coal or natural gas burned to produce electricity, or biomass burned for fuel. If you've ever been sitting around a campfire and felt you needed to move because the wind started blowing the smoke or particulate matter into your face, then you've experienced combustion byproducts. For most environmental regulations, you can easily find them through the US EPA's website. This is true for criteria air pollutants, so let's look them up. You can see links to information on each of the pollutants, and I highly encourage you to look through those. I am not going to go through each one of them today. We're going to click on the summary table of the current NAAQS, which is the National Ambient Air Quality Standards. This shows you the standards for all of the criteria air pollutants. You can see the pollutant and its chemical symbol on the left. Then you see a column for primary and secondary standards. Primary standards are standards that protect public health, including sensitive populations like children, elderly, and people with respiratory conditions. Secondary standards protect public welfare and address things like visibility, damage to buildings, animals, and vegetation. The next column is averaging time, which is exactly what it sounds like. For example, carbon monoxide, CO, samples would be averaged over a period of 8 hours to get the number. And then we have a level, which is the concentration, and form, which tells you about how the standard is assessed. So for example, the average carbon monoxide concentration over an 8-hour period should not exceed more than 9 ppm, parts per million, more than once a year. Likewise, the rolling 3-month average of lead should not exceed 0.15 micrograms per cubic meter. These are two concentrations, ppm or parts per million and micrograms per cubic meter, that are very common when you're talking about air pollutants. We'll talk more about them in another video. One other thing that you'll see on this webpage is PM 2.5 and PM 10. So these are two sizes of particulate matter, PM. PM 2.5 includes particles smaller than 2.5 microns, or micrometers, and PM 10 includes particles smaller than 10 microns, or micrometers. For reference, human hair is about 100 microns in diameter. As far as nomenclature goes, in addition to primary and secondary standards, which I just explained, there are also primary and secondary pollutants. Primary air pollutants are those that come directly from natural or anthropogenic sources. They include particulate matter, carbon monoxide, sulfur dioxide, among others. And secondary air pollutants form when the primary air pollutants react in the atmosphere. One big secondary pollutant is ozone, ground level ozone, which forms when NOx reacts with volatile organic compounds in the presence of sunlight. So regulating something like ozone is a little more complicated because you have to regulate the chemical precursors. When air quality is reported, it's helpful to have only one descriptor that tells us if the air is good to breathe, rather than just reporting to the public different concentrations of different pollutants. So this is the air quality index, which is used to determine if the air quality, as you might have seen in the news, is good, moderate, unhealthy, hazardous, etc. If you live in Butte, the health department actually has a pretty big sign on Front Street that displays the air quality for the day. This descriptor, healthy, moderate, unhealthy, etc., is based on a number called the air quality index. The air quality index is on a scale from 0 to 500, and the higher the number is, the worse the air quality is. So I want to show you here a table of the air quality index, and you can see basically how these colors correspond to levels of concern and particular values that the air quality index has. So this number is calculated using the concentration of the criteria air pollutants. For each pollutant, you would calculate an air quality sub-index. If you have some pollutant data for an area, you can use this table to see where each pollutant falls. These are called breakpoints. And then if, like let's say your pollutant falls within these two concentrations, you can use linear interpolation to calculate the exact air quality index. So if you have several pollutants, you find the air quality index for each of those pollutants, and then the highest sub-index will be your air quality index. So basically the pollutant that is worse drives the air quality index. Let's do an example of an air quality index calculation. So first we can look up today's ambient air quality in Butte. When I look outside my window, it appears to be pretty good. We have wildfires here, and on a bad wildfire day, when I look out my window, I don't see much. But today the air quality looks pretty good. And this is true for most places in Montana. So the driving force for air quality is often particulate matter from wildfires. So I could only find data on particulate matter, specifically PM 2.5, so I'll just use that. This is really the main pollutant in this area. You can find this data for all monitoring stations in Montana on the Montana Department of Environmental Quality, or DEQ, website. So a quick look at this map here shows that the air quality is good to moderate throughout the state right now. You might want to look at a map like this if you're trying to decide where to hike or camp, if there's some wildfires going around. you can choose a spot with good air quality, because no one likes going on a hike, getting to the top of the mountain and seeing a whole bunch of smoke. So if we click on Butte, we can see the current numbers. This graph shows concentration versus time per today. I like the way this graph is color-coded, so you can very easily see how good the air quality is. So right now, this line, and all throughout today, this line has been in the green, which is good. If I scroll down, I can see that today's average PM2.5 concentration is 4.9 micrograms per meter cubed. And if I look at our table, I can immediately see that this is within the good range, with an AQI of 0 to 50. However, I may want an exact air quality index for today. So let's do that calculation. So what I'm going to do is actually use some of the data from yesterday, and I'm looking at the 24 average for PM 2.5, and it just so happens that that is also 5.2 micrograms per meter cubed. Next, what I need to do is I need to look at my table of breakpoints in the air quality index, and I need to specifically look at that PM 2.5 24-hour average. And what I see is that I'm definitely within the good category here because I'm less than 12 micrograms per meter cubed. Now, if that's not satisfactory enough, but maybe I actually want to get a number for the AQI, what I'm going to need to do is linear interpolation in order to figure out exactly where I am within the good range. So here's an equation for that linear interpolation. IP is the index of the pollutant, which is the air quality index that we're looking for. And then BP, high and low, those are those breakpoints. CP is my concentration, which is 5.2 micrograms per meter cubed. The breakpoints for good are between 0 and 12 micrograms per meter cubed, and the corresponding AQI values are 0 and 50. So basically, all I need is that information to do this linear interpolation. Before I do this, I want to kind of just jog your memory for how this works. So basically, I have my index, and I have some concentrations. The breakpoints on the table and the corresponding air quality indices make these 2 points on this line. And basically what I'm going to do is look at the slope and the intercept of that line in order to figure out where exactly, what my exact index is for a given particulate matter concentration. Okay, but now, so this right here is going to be basically our slope, so our change in y over our change in x. So for now, I'm just going to plug everything into this equation to solve for my air quality index. So my high AQI value corresponding to the breakpoint is 50. I'll divide that by my difference in breakpoints, multiply it by the difference between my measured concentration and the lower breakpoint, and then the lower AQI is 0, so I'll just add 0. And what I get is 22, and it has no unit. So this actually makes a lot of sense because 22 is about in the middle between 0 and 50, and our measured value, 5.2, is about in the middle between 0 and 12 micrograms per meter cubed. This was a relatively simple example. However, if you were in a larger city with more air pollutants, you would perform this same exact calculation using the table for each pollutant, and then you would choose the highest air quality subindex to use as your air quality index. So this concludes our introduction to air quality. I've only given a really brief overview here, and I hope that you will look at the associated links and learn more about air quality and the criteria air pollutants on your own. But here are some major take-home points for today. So first, ambient air is the air you breathe outside. It's not indoor air, and it's going to be the air close to the ground, what you're actually breathing. The Clean Air Act identifies 6 criteria air pollutants. You should memorize these. So ground level ozone, carbon monoxide, sulfur dioxide, small particulates, nitrogen dioxide, and lead. National ambient air quality standards exist for all of the criteria air pollutants. Primary standards protect public health, including sensitive populations, and secondary standards protect public welfare. And they address things like visibility, damage to buildings, animals, vegetation. Primary air pollutants are those that come directly from natural and anthropogenic sources, while secondary air pollutants form when the primary air pollutants react in the atmosphere. So remember, we have kind of like two types of definitions that include these words, primary and secondary, so you have to pay attention. And finally, the air quality index can be calculated using concentrations of the criteria pollutants. And it's a single number that gives an indication of the overall air quality. And if you are given air quality data, you should be able to calculate the air quality index. Now that you know a little bit about air quality, look into air quality in your hometown. Is it good? Is it bad? Are there particular air pollutants that happen to be an issue? Where do they come from? Does the air quality change within a given day or between seasons? Maybe some particular neighborhoods have really bad air quality while others don't. And then finally, what can you do personally to improve the air quality in your area?